Good evening, everyone. Today I'd like to continue to talk about Chainlink CCIP. In particular, we're going to focus on one of the components called a NonceManager. You have NonceManager on Chain 1 as well as on Chain 2. So what is NonceManager? Basically, it's used to retrieve and increase nonce so that message, if we want, can send from Chain 1 to Chain 2 sequentially. You cannot have out of order execution. So you cannot, for example, execute message 5 first before you execute message 4 if you want to enforce it. Okay, so let's see how that's done over here. Let's look at the code. First of all, this is achieved by NonceManager. So this manager have a few data structure over here, 3 mapping. This is data structure used for managing the upgrade, because previously they have on ramp for every source chain, and they have off ramp for every destination chain. So that simply means on every single chain, they are going to have many off ramps and many on ramps. Let's give an example. Suppose we are talking about 10 chains. Then in every single chain, you need to have 9 off ramps and 9 on ramps. So which is a lot of ramps, I understand. So given 10, we are talking about 18 ramps on each chain. So 18 times 10, we are talking about 180 ramps as a total. So it's not so scalable. So in this new version, they improve it. So now on every chain, there's only 2, 1 on ramp and 1 off ramp. Doesn't matter how many chain out there. So it's much more scalable, because now instead of multiplication, it becomes addition, which is 2 times 10 only need 20 ramps, 2 for each chain. So that's improvement. So in order to support this upgrade, they introduced this data structure to remember the previous ramp they used for every chain, including source chain, including off ramp, and including on ramp, so that the nonce that used to be stored in the ramp can be imported here to continue the game. And then this is remember the out of bound nonce. This is remember the inbound nonce. What's the difference? Well, the difference is you move from chain 1 to chain 2. So on chain 1, you are going to have the out of bound nonce. And in chain 2, you are going to have the inbound nonce. So that means if you have 1, 2, 3, 4, 5 over here, then on chain 2, there might be having to be a lag because some message still on the row, some messages are not executed yet. So it typically this will also lag a little bit, right? So that's 2 nonce, but both of them is actually a nonce mapped to a triple. You only see destination, selector, sender. You don't need to remember the source chain because this NonceManager is already on a chain. So the source chain is implicit. The chain that this NonceManager runs on, that's the implicit source chain for this variable. And then that's the implicit destination chain for this variable also. You might feel this is a little bit confusing. The reason why it's a little bit confusing is because imagine over here when you look at this slide, I call this one source chain, this is one destination chain, but this is really relative. Chain 2 could be a source chain 2, and chain 1 becomes a destination chain. So in other words, you can also send a message from chain 2 to chain 1. In that case, you're going to use the on ramp on chain 2, and then send to the off ramp on chain 1. So it's just magic, okay? And this is why you might feel it's a little bit confusing, but once you get this clear, I think it should be easy to understand. So in other words, if you are talking about outgoing messages, you look at this one. But if you are looking at incoming messages, then you are looking at this one. So who is going to look at outgoing message on ramp, right? And who is going to check incoming messages, the off ramp, right? So in the beginning, they are doing some authorization. So only the, only this list of authorized caller can call all these functions. So basically, you can imagine it's just in this case, it's just the I would imagine just need two edges on ramp and off ramp, or maybe there are any other edges because there's two right now. And then the first function is called get increment on bound nonce. So that means this is function is going to be called in the on ramp side before you send a message, and it's right here, okay, which is on ramp over here. In the if you still remember from previous video, it's in the forward from router that's called by router. So here you call get increment out of bound downs. You basically you're going to increase by 1. So you have two options to send message. Either you allow of order execution. If you allow, you set to 0. So this, so the so over here you only enforce the order only when it's not equal to 0. If it's equal to 0, you're going to skip this if. You're not going to enforce it. And if you want to enforce it, then you call NonceManager get increment out of bound nonce. So what you are going to do is you get the current nonce and increase by 1 and then store it back. Okay, it's easy operation. But the get out of bound nonce is doing some code that connect to legacy code. So over here, if the current out of bound nonce is 0, that means this is the first message ever that's sent, at least as far as the new version of NonceManager is concerned. So you want to look at legacy system, remember we have a lot of ramps before. So over here we check out, what is the previous on ramp? Because the previous on ramp will remember the outer bound nonce. So if it's not 0, then you're going to call this function. So probably over here you have to look at the code of previous ramp and see how this function is implemented. But as you can imagine, still the nonce is going to be based on a triple of source chain, destination chain, and the sender. Once you get the nonce, then you return it. So this is one that take care of the legacy code. I was curious if both the new system and the old system is working, and both of them are working on nonce. I was just curious if this is going to get into a race. Do we have a race condition? Unless they might just pause all the existing ramps, and then in that case, then this is read only. By pause, I mean they cannot advance the nonce anymore, but you can still call their view function, not update function. And this way, the old system can serve the purpose for view, but not serve the purpose for update the state variable. So that's how the get out of bound of nonce work. And of course, you can also call it to get the nonce without increasing it. So what about get increment inbound nonce? As we can see from the off ramp over here, if nonce is not equal to 0, that means we're going to enforce the order. And then the order will be enforced when the message has never been executed. So this line means the message has never been executed. If it's executed before, regardless of the final state, a successful or failure, even it's a failure, then the nonce already has been incremented. So in that case, you don't want to increment again for the same message. Okay. So in this case, so this is already, so this will increment. So this function is going to call NonceManager increment inbound nonce. We can look at what it's doing. Basically, what it's doing is get a current inbound nonce, and again, it's pretty similar. It's going to retrieve the value if it exists, and if it's 0, you just maybe this is the first message. You want to check if we have the nonce already stored in the old system. If it's there, we retrieve it, so we can continue to work in the new version. And then the get inbound nonce, once we get it, we are going to check if it's going to be equal to the expected nonce. So the expected nonce basically is the nonce from the message. Okay, so the message nonce have to match with the current nonce count number in the NonceManager. If they match, that means it's in sequence, not out of order. Then we can proceed. Otherwise, we are not going to not allow it. Okay. In this case, not allow it means continue. So the message will simply be skipped, and they probably can execute other message over here. Okay, because it's already out of order. Okay, and then let's see. The next thing you do is go down, get inbound nonce. We talked about this already. I think very much we are done for this. And then this is just a function to apply, just try to store for all the previous off ramp and on ramp. There's one more thing over here. They check if overwriting is allowed. If it's not allowed, you cannot override a existing configuration. Otherwise, you can reconfigure it. So just save the ramp, on ramp, and off ramp for every single. So you can change every single descent. So this is an update which I enjoy. So you can perform multiple update for multiple chain for each chain at the same time. Okay, so if if you want to update 9 other chain, you just have this element, and this array have 9 elements over here. All right, so I think that's very much for the NonceManager. Thank you so much. Have a nice day.